When we are writing down the substitution part, right? I hope you're understanding that C2H6, if I write down the elaborated structure here, and if I combine this with what? With fluorine, and I put it in dark also, even in the dark room also, I perform this reaction. So all the hydrogens would be in a single go, would be replaced by fluorine, would be replaced by fluorine. You understand my point? And along with that, how many hydrogens do you think we have? Six. So all for one hydrogen, there shall be one F, because H and F, you see the bond. One, two, three, four, five, six, seven. And hydrogen is one. So one hydrogen needs one fluorine to complete its octet, which is why for one hydrogen, one fluorine would be required. Understood or not? So this is fluorination
Yeah.
of alkanes. Any doubts on this?
No.
Right. All right. So this is one thing we have. Then you have a look here. Then the next property of alkanes is the cracking. Cracking of alkanes. Right? When we are talking about the cracking of alkanes, exactly what happens, just see. When we are talking about the cracking of alkanes, you understand?
Yeah.
So what is happening? Just understand. We have big amount of alkanes, a long alkane you can take. For example, you prefer taking a carbon chain of, let's suppose, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's suppose you have 11 carbon atom chain. And obviously the hydrogens definitely would be there. So CH3, CH2, 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 and CH3. You know? And when you heat it at a high temperature, at a very high temperature and pressure, you see? So at your own will, you can break it down. Sometimes if you're heating it consistently, so it might break into three carbon chains and then four carbon chains and then two carbon chains and two carbon chains. This is how it could break. So basically cracking means the breakdown of a bigger alkane into a smaller alkane. Breakdown of a bigger alkane into a smaller alkane, that is called cracking. Do you understand? So you can write down at your own will. अपने आप से you can think of and you can write it down that let us suppose, ma'am, it forms CH3, CH2, CH3. Plus it can form CH3, CH3, CH2, CH2, CH3. So one carbon or one alkane of four carbons. Then two alkanes of two carbons. So that's how we can think of. So what is cracking? Cracking means the breakdown of a bigger long chain alkane into a smaller chain alkane. You understand my point? That is alkane.
Yeah.
That is cracking of alkane. So what I'm trying to tell you is that
Yeah.
the reactions of alkanes are basically one category, that is substitution. Replace one H either with bromine, so you get bromination. Replace one H with chlorine, so you get chlorination. Replace one H with iodine, you get iodination. Replace one H with NO2 using concentrated HNO3, you get nitration. Replace one H with SO3H, so you get sulfonic acids. You add H2SO4. You can break a bigger alkane into smaller alkane. You understand? So these are the basic properties of alkanes. But I'll tell you one more thing in detail. Very, very important part. So what do you think we have it right here? Just see. When we write down chlorination, you know, there is a limit to chlorination. It's very simple. When you talk about methane, only this example generally comes in exam. So you understand. When you write down chlorine in the presence of sunlight, you understand? And let us suppose I have taken chlorine in excess. Chlorine isn't taken in excess. See what would happen. What would happen? Just see. So we have C, H, H, NH, and one H shall be replaced by chlorine. Am I right? And
Yeah.
because we have Cl single bond Cl, I hope you're understanding that HCl shall be removed and HCl is formed here. But because chlorine is in excess, it will keep attacking and it will keep replacing the H's. So in the second step, when you have kept the beaker in the sunlight, so we have one chlorine here and one H right here, one H right here, one H right here. You understand? And we have chlorine single bond chlorine. So HCl shall be formed. And here what is going to be formed? Sunlight shall be here. I hope you're understanding. So it is going to be
Yeah.
C and H and H. Both H's are there. These two H's are right here. And this one H was actually becoming chlorine, has actually become chlorine. Because this chlorine was actually a substitution of hydrogen in the first step. This
Yeah.
shall be your step two. So what would that become? It is going to become chlorine again and HCl. So I hope you're understanding this chlorine comes at this H's place. And now you see two hydrogens are actually replaced by chlorine. Now the next step, step number three, we have C, Cl, and Cl, and one H here and one H here. Again, you add down chlorine. You understand? So HCl shall go
Yeah.
again in the presence of sunlight. And then what is going to happen? At this particular place, we will have C, Cl, and H, and Cl, and Cl. And we will have HCl. Understood or not?
Yeah.
And on the similar lines, when you add again chlorine, so the last H shall also be replaced, and thereby all the flow four hydrogens shall be replaced by chlorine. You understand my point?
Yeah.
What does that mean?
Yeah.
That this is not a single step reaction. This is an excess. This is a four-step reaction. So think of an alkane which will have six hydrogens in it. So it would become a six-step reaction until all the hydrogens are being replaced by chlorine.
Chlorine.
So this is a
Is this
six-step.
also only with chlorine?
Yeah, only with chlorine. Only with chlorine, and that too when chlorine is in excess. I hope you're understanding the method. So
Yeah.
today I have covered up all possible substitution reactions in alkanes. And I have covered the chemical properties of alkanes with you. That how would an alkane behave in different situations? It could be combusted, right? Energy could be produced. It could be combusted either completely or incompletely, depending upon the amount of oxygen present. you know and why do we
Yeah.
burn anything? We burn anything to produce energy out of it, and to make use of that energy. So if energy is very high, definitely it is of use to me. And if energy is very less in quantity, definitely I'm burning the fuel also, but I'm not getting enough energy out of it. You understand? So I'm basically sort of
Yeah.
wasting my fuel. So you have to understand that what chlorination basically, what alkanes or how alkanes sort of behave in different conditions. Is that clear in this part?
Yeah.
Right? So
Yeah.
this is it. This is it for alkenes. Understood or not?
Yeah. Understood.
Right? Okay. So I'll see you tomorrow then. Tomorrow, no, whatever the day